Welcome to Hyfindr Expo-Highlights at the Hamburg Hydrogen Technology Expo. Today at Vega with Mario Grimmeißen. Mario, what are you guys presenting?
So we at Vega, we are experts in level and pressure measurement.
All right.
So we have different applications in the hydrogen sector, like production of hydrogen, storage of hydrogen, and we supply the measuring tools for level and pressure.
And pressures. Okay.
Yes.
Right. So we have an example application here. This is, what do you measure here? Pressure.
This is a model for storage tanks. Yes.
Yes.
In that case, it's a gaseous storage tanks, so we have very high pressures.
Okay, so this can go up to how many bar?
The sensor can measure up to 1,000 bar.
Okay.
Usual process pressures in storage tanks is like 700 bar.
700. Okay, so yeah, this one reading at 694. Yeah, well, so that's next to this setup. What is this?
Yes, before we can store hydrogen, of course, we have to produce it first.
Yes.
So this is an example and model for an electrolyzer.
Right.
In that case, it is a PEM electrolyzer. You see in the middle the proton exchange membrane.
Right.
We have two sides, like the oxygen side and the hydrogen side.
Right. And then you have sensors on those. What are you measuring?
Yes, in that case, we are measuring the level. On the one side, the ultra-pure water. On the other side, the excess water, to always ensure that both sides are in balance, that the process is running efficiently.
So on this side, you're measuring the pressure on the pipes with this one here.
Yes.
And here you are measuring how much water there is. How do you measure? What kind of sensor is this?
This is a radar sensor.
It's a radar sensor.
This sensor sends out radar signals. It's getting reflected by the surface of the liquid, and it's coming back to the sensor. And that's how we measure more or less the distance.
Yes.
And within the electronic, we can switch that to the level of the tank.
Right. And that you have on the air side, on the, let me say, hydrogen side. You can see it here as well.
Yes. So both have more or less similar requirements. On the one side, of course, the oxygen side, then the protons getting through the membrane, and on the other side, the hydrogen gas is produced. So we have the ultra-pure water on the one side and the excess water on the other side.
Okay.
And both has to be measured continuously.
Yes.
That it's always in balance, that the process is running safe and efficient.
Okay. And I see you have a level sensor here. Maybe we can show that in the camera a little bit later. But you have a level sensor here, and that detects when liquid passes a certain level, right?
Yes.
Maybe we can show that here. So it's actually submerged right now. And what kind of a sensor, how does it measure?
So this is more or less just the safety device. So when the continuous level measurement is stopping or is not working because of any reason, and the level is dropping down too much, we can connect this one with the central
plant control.
Yes, plant control.
Or safety systems, yeah.
Yes.
And then
this is a vibrating level switch.
Okay.
So it's vibrating in a continuous frequency. And when the water is going too low, the air is around this.
Yes.
So the frequency is changing, and that's what we give as a measuring output.
As a measuring output. Okay, so that's how the level sensor works, and this is a radar one that sends radar down, and the pressure ones. How do those pressure sensors work? Yeah.
So yes, in that case, in this application, we have the pressure sensors in the feed line and in the discharge line.
And there you had an example here.
Yes, I have an example here. So we are known for the ceramic measuring cells at Vega.
Yes.
Which has some advantages. When we talk, for example, about hydrogen, also in storage, for example, as a gas, we always talk about diffusion.
Okay.
So that means when the hydrogen gas is diffusing through something, whatever, like stainless steel or ceramic, it can blow up the oil.
All right.
And usually or often pressure sensors are produced with an oil filling.
Okay.
And the advantage with the ceramic measuring cell is that we don't need the oil filling.
Oh, you don't need, okay.
So it is a dry running measuring principle.
All right. Okay, and on which side does the hydrogen actually come up?
Yes.
On which side?
It's not really diffusing through the base body. So to tell it like this, the ceramic measuring cell consists of two main parts, the base body and the membrane. And they are both fixed together with a glass seam.
Yes.
and they are building like a parallel plated capacitor.
Okay.
And when the pressure is coming on the membrane in the process,
Yeah.
the distance between these two plates are changing,
Okay.
and the capacity is increasing.
Okay, and you measure that, and that's how you get your.
That's how we measure the pressure.
Wow, excellent. Thank you. You have one more setup here, which looks actually pretty impressive. What is this?
Yes, so earlier we talked about pressure measurement in the gas tanks.
Yes.
But also there are sometimes storage with as a liquid,
Okay.
liquefied hydrogen.
Yes.
And we have some special requirements there because hydrogen is getting or turns to a liquid at minus 253 degrees.
Okay, so we have it all in here. This is the tank, and you can see it's all liquid hydrogen already in the base.
These are called like cryogenic tanks.
Cryogenic tanks.
Very deep temperatures.
Understood. Okay.
Yeah.
And your sensors can withstand that.
Yeah, they can.
Okay. And how do you measure now on this? What are you measuring here?
So in the liquefied storage tank, it's about level measurement of the liquid.
Mm-hmm.
And because of this deep temperature, there's not a few options with different measuring principles like radar or something else. So we have to use differential pressure.
Differential pressure. All right. Okay.
So we having two different pressures in the tank. The pressure of the liquid, the hydrostatic pressure,
Yes.
and the pressure of the gas.
Okay.
And in that case, we have one pressure measurement on the top side and one.
Maybe we can just show it from this side here. So we have we have one meter here that is connected to two.
Yes, this is so like this is the pressure sensor
This is the pressure sensor,
with
right?
two impulse lines.
Okay.
One is going to the top side, measuring the gas,
Yes.
and the other impulse line is going to the downside, measuring the liquid. But as the gas is also pushing on the surface of the liquid, so we
Yes.
have both pressures on the downside and only the gas on the top side. And then we can do the mathematics behind it to only get the hydrostatic pressure to have the level.
Okay. And are there two pressure sensors for both sides, or is it just measuring the difference between?
Yeah, it's only measuring the difference.
It's only so on your
Like
plates you have on one side
membrane, and both is pushing from each side.
from each side. Okay, right. So
And-
that's at the top and the bottom. Okay.
And the difference is that what stays.
And high reliability, low temperatures. Anything you can add in terms of what makes this special?
Yes, of course. On the one hand, it can deal with the very deep temperatures. On the other hand, these are all processes with special requirements, like X approvals, like seal, safety integrity level. So in that case, it's mostly about reliability and making the processes running safe and efficient.
So that's your specialty.
That's what we do.
Okay, cool. And this up to what? Is it minus 270?
253 years.
253 degrees. Okay, wow, okay. Well, that's absolutely exciting.
Yeah.
We wish you all the best for this, and this is probably going to be a very impressive thing for many people to look at this show. So thank you, Vega. Thank you, Mario, for having us.
Thanks
and I
for
wish
having
you all the best.
Have a good day.
Thank you, Mario.